All right, get ready to explore the amazing world of quantum science.
Yeah.
We're going to take a deep dive into an essay by Yorgo Schneppet
Okay.
that looks at the core principles of this field, how it changes the way we see the universe,
Right.
and its impact on the real world. And guess what?
What's that?
This essay was originally written in German, but we've translated it just for you.
Very cool.
So,
Yeah.
let's get started.
Well, what's fascinating is how quantum science actually emerged from the limitations of classical physics.
Uh-huh.
I mean, for centuries, Newtonian mechanics
Yeah.
and electromagnetism worked great,
Yeah.
but then they hit a wall. They just couldn't explain some things,
Like what?
like black body radiation. That's the way objects give off light when they're heated up,
Okay.
or the photoelectric effect.
What's that one?
That's how light can knock electrons off a metal surface.
So classical physics couldn't keep up with these new observations,
Exactly.
like trying to fit square pegs in round holes, huh?
That's a good way to put it.
So how did we move past these issues?
Well, these discrepancies led to a huge revolution in physics.
I
It
said,
started with Max Planck
uh-huh.
and his pretty radical idea of energy quanta back in 1900.
Okay.
He basically said that energy doesn't flow smoothly,
Yeah,
but instead exists in these separate little packets.
like small bundles.
Yeah, exactly.
Wow, that's a big shift in thinking.
And then came Einstein.
Oh, yeah, what did he do?
He took Planck's idea
Uh-huh.
and used it to explain the photoelectric effect.
Hmm.
He showed that light itself is made up of these little energy packets,
Which are called...
photons,
Right, so that changed how we think about light
completely.
and energy.
Absolutely.
So this is all about quantum mechanics.
Yes, these discoveries laid the foundation for it.
Right, which is like the basis for quantum science, right?
Exactly.
And quantum mechanics describes the universe at the smallest scales.
Yeah, and at those scales, things work very differently from our everyday experience.
So it's kind of like discovering a whole new set of rules for the universe.
Yeah, that's a good way to think about it.
That's pretty cool.
It is, and then as quantum mechanics developed, two main theories came out.
What were those?
Heisenberg's matrix mechanics
Okay.
and Schrödinger's wave mechanics.
So were they like competitors or did they work together?
It was kind of both, actually.
How so?
Well, Heisenberg focused on what you could actually observe,
Okay.
like quantities and how they were connected,
Uh-huh.
and that's how he came up with matrix mechanics.
Interesting.
Schrödinger, on the other hand, he described quantum systems using wave functions.
Wave functions.
Yeah, they're like mathematical descriptions
Got it.
that show how these systems change over time.
So that led to...
Wave mechanics.
And they both arrived at the same conclusions.
Yeah, which is crazy, right?
It is. So different approaches,
Yeah.
but the same results.
That's quantum mechanics for you.
Wow, that's fascinating.
So now let's get into the weird stuff.
All right, the things that make quantum science so interesting.
Yeah, like quantum entanglement.
Yorgo Schneppet talks
Yeah.
about a bunch of these in his essay.
Right.
And that one always kind of creeps me out, to be honest.
It really does challenge our normal intuition.
Yeah, you have these two particles that are somehow linked
Uh-huh.
in a way that almost seems to defy physics.
It's like they're connected no matter how far apart they are.
Like, if you measure one particle,
Yeah,
you instantly know the state of the other,
exactly.
even if they're miles apart.
It's pretty wild.
So does that mean they're communicating faster than light?
Well, not exactly.
Because it's not supposed to be possible, right?
Right. According to Einstein,
Yeah.
it's not really about faster than light communication as we understand it,
Okay.
but it suggests a level of interconnectedness that we're just beginning to grasp.
So instead of separate
You're
particles,
part of a single entangled system.
no matter how far apart they are.
Precisely.
That's crazy. It's a completely different way of looking at reality. It really is.
And then there's superposition.
Yeah, that's a fun one.
It's like the idea of being in multiple states at the same time.
Exactly.
Like Schrodinger's cat.
Right.
That's a mind-blowing concept.
It's-
So until we observe a quantum system,
Yeah.
it exists in all possible states simultaneously.
That's the idea.
How is that even possible?
Well, that's one of the biggest mysteries in quantum mechanics.
I can imagine.
It seems like when we measure it,
Yeah.
it forces the system to choose a single state.
But what does that really mean?
No one knows for sure.
Really?
Some people think the other states just vanish.
Okay.
Others believe they continue to exist
In
in parallel universes.
Whoa. Parallel universes.
It's pretty deep.
That's too much for me to handle right now.
It's hard.
But it does make you think about reality
Definitely.
and how much we don't know.
For sure.
Okay, one last mind-bending principle.
Which one?
Wave-particle duality.
Yeah, it's classic.
So particles act like waves.
And waves act like particles. It's like they can't decide what they are.
Uh-huh. Sort of.
Schneeppert mentions the double-slit experiment in his essay.
Oh, yeah, that's a great one.
It shows how particles.
Like electrons can be both waves and particles.
So what are they really?
It's not that they're one or the other.
Okay.
It's that our classical ideas of wave and particle don't really apply to the quantum world.
I see. So they have this dual nature,
Exactly.
and we're just trying to put them in categories that don't really fit.
That's a good way to put it.
So this is all very interesting.
Yeah.
But it's not just theoretical, right?
But no, not at all.
These quantum phenomena have real-world applications.
Absolutely, and that's what we'll talk about next.
Right, because they're already impacting our lives.
For sure.
So we've laid the foundation.
Yes.
Now it's time to explore the practical side of things.
That's coming up next.
All right, stay tuned, everyone,
We'll be right back.
with part 2 of our deep dive into quantum science.
Guided by Yorgo Schneebert's essay.
So don't go anywhere. Welcome back, everyone.
It's great to be back.
We've been talking about the crazy principles that govern the quantum world.
Right, the foundations of quantum science.
Exactly. And now we're going to shift gears
Okay.
and focus on the practical
Doing
side.
real-world stuff.
Yes, the real-world impact of these quantum phenomena.
Right, so how do these principles actually affect our lives?
So let's jump right in.
Let's do it.
Yorgo Schneeppert highlights some amazing applications in his essay.
He does, especially in areas like quantum computing.
Okay, quantum computing.
Yeah,
That's something I hear a lot about,
it's a hot topic.
but I still struggle to understand it.
It is complex.
So what makes quantum computers so different?
They're fundamentally different from classical computers.
Okay, how so?
Well, classical computers use bits.
Right, which are either 0 or 1.
Exactly.
But quantum computers use qubits.
And those can be both 0 and 1 at the same time.
Wait, how is that possible?
That's where the magic of superposition comes in.
So they're like doing multiple calculations simultaneously.
That's the idea.
That's mind-blowing.
It is, and it gives them enormous processing power.
So what kind of problems can they solve?
Problems that would take classical computers
Yeah.
maybe millions of years,
Whoa.
like simulating complex molecules
For things like drug discovery.
and materials science.
Right, because those simulations are very complex.
Extremely complex.
And classical computers struggle with that.
They just can't handle it.
But quantum computers can.
They can.
So we could test and design new drugs and materials virtually.
That's the potential.
That would be revolutionary.
It would completely change those fields.
And what about cryptography?
Quantum computers could break our current encryption methods.
That sounds scary.
It's a concern.
But they could also help us develop new, unbreakable encryption.
That's the other side of the coin.
It's like a double-edged sword.
It is. Powerful technology always is.
So quantum computing has huge potential.
In so many areas.
Okay, let's talk about quantum communication.
Another fascinating area.
I know security is a big focus there.
Yeah, quantum communication offers incredible security.
How does that work?
Well, it uses the principles of quantum mechanics
Okay.
to create unbreakable encryption keys.
So it's like a super secure way to transmit information.
Exactly.
Schneeppert talks about the BB84 protocol.
Right, it's a prime example.
It uses entangled photons.
You create a secure channel,
And if someone tries to eavesdrop,
the system immediately knows.
so it's like having a built-in alarm system.
That's a good analogy.
Is this technology already being used?
Well, it's still early days,
Okay.
but there are already quantum communication networks in
Right.
places like finance and government.
Where security is crucial.
Absolutely.
So quantum communication could really change the game.
It has that potential.
Now, what about quantum sensing?
Quantum sensing is about using quantum systems to make incredibly precise measurements of things like gravity, magnetic fields, even time.
More precise than classical sensors.
Much more precise.
Wow. What are the implications of that?
It could revolutionize things like navigation,
I see.
geophysics,
Right.
medical imaging,
Right.
even environmental monitoring
So we could detect underground resources
with pinpoint accuracy.
or predict earthquakes more effectively.
Exactly.
This is incredible.
That's pretty amazing.
But with all these advances,
yeah.
we have to think about the ethical implications.
Of course, we can't just ignore those.
Schneeppert talks about this too in his essay.
He does. He emphasizes the need for responsible development.
Right. So what are some of the ethical concerns?
Well, quantum computers could be used for malicious purposes,
Like what?
like breaking into secure systems.
I see. That's a big concern.
It is. We need to develop new security measures.
Like counter those threats.
Exactly. And we also need to consider access.
Access to these technologies.
Yes, we need to make sure they benefit everyone.
And not just a select few.
That's crucial.
So responsible development
And equitable distribution.
are key to navigating this new world.
Absolutely. It's a shared responsibility.
We all need to be involved.
Scientists, policymakers, industry leaders, everyone.
We're at a pivotal moment.
Yeah.
The choices we make now will shape the future.
Of quantum science and its impact on humanity,
So where do we go from here?
that's what we'll explore in the final part.
The final part of our deep dive.
We'll look at the challenges
The possibilities.
and the potential breakthroughs that lie ahead.
So stay tuned for part 3.
It's going to be a fascinating discussion.
And we're back for the grand finale of our quantum journey.
The final frontier.
Exactly. We've covered those incredible quantum mechanics principles, looked at how they're used, and talked about the ethics, all thanks to Jorgo Schneepat and his fantastic essay.
He gave us a lot to think about.
He did. So now, what's next for quantum science? What's on the horizon?
Well, the future of quantum science is super exciting, but it's also a bit of a mystery. In a way, there's so much potential, but also a lot of challenges to overcome.
Like what kind of challenges?
Schneepat talks about this in his essay, especially with quantum computers.
Right. We talked about scalability before.
Yeah, building those quantum computers with more and more qubits, which are like the heart of their power, is a big problem.
It's proving to be really tough. Why is that?
It all comes down to the qubits themselves. They're incredibly sensitive.
That's sensitive.
Yeah, to their environment. I mean, even tiny disturbances can cause errors.
I see. And that's called
Decoherence.
decoherence, right?
It's like trying to build a house of cards in the middle of a hurricane.
Oh, wow.
Yeah, it's a huge obstacle.
So how are scientists trying to get around this?
There are a few promising ways they're tackling it.
Like what?
Well, one way is to create tougher qubits that aren't so easily affected by noise.
Makes sense.
And then there's error correction.
So kind of like how regular computers handle errors.
Similar idea, but it's way more complex with quantum systems.
I bet.
And there's this really cool area called topological quantum computing.
Okay, that sounds interesting.
It uses these like bizarre states of matter to create more stable qubits.
So it's kind of like a different approach to building the qubits themselves.
Exactly.
Fascinating. So Schneepat mentions quantum supremacy, right?
Yeah, that's the ultimate goal.
The moment quantum computers can actually outperform classical computers in real-world tasks.
And there's a race to get there. It's global.
That's wild.
Yeah.
So how could this affect different industries? What's the impact going to be?
Oh, it's potentially huge.
Huge.
Think about medicine.
Okay, medicine.
We could use quantum computers to simulate complex biological stuff, like how diseases work at the molecular level.
That's amazing.
We could design drugs tailored to each person's genes.
Personalized medicine, wow.
Yeah. And what about material science?
Oh, right, we talked about that earlier.
Imagine discovering brand new materials with properties we've never even seen.
Using quantum simulations.
Exactly. It could revolutionize everything from building materials to energy.
That's incredible.
And don't forget AI, artificial intelligence.
Right, how does that fit in?
Well, quantum computers could analyze massive amounts of data, finding patterns that classical computers miss.
So much faster.
Yeah, it's a game changer for AI.
Like a super boost.
Yeah.
But with all this amazing technology, we have to think about the consequences.
Absolutely. Schneepat is really clear about that.
Ethical considerations can't be ignored.
Yeah, these technologies will become more and more a part of our lives. We have to consider privacy and security.
It's like opening a whole new can of worms, in a way.
It is, and we need to be ready for it.
So it's not just about building the best quantum computers.
No, it's about using them for good, for the benefit of everyone.
We need rules and guidelines.
And open discussions involving scientists, politicians, business leaders, everyone.
It's a huge responsibility.
It is, and I think Schneepat puts it beautifully in his essay. He says, exploring this quantum world isn't just about technology.
It's about self-discovery.
Exactly. It makes us question our place in the universe. It pushes us to learn and grow.
Wow, well said.
Thanks.
It's been an awesome journey exploring quantum science.
I agree.
Big thanks to Jorgo Schneepat for his amazing insights. His essay really helped guide our deep dive.
It did.
And thank you, everyone, for listening. We hope you've learned something new and that you'll continue to explore these incredible ideas. Keep questioning, stay curious, and who knows what amazing discoveries await us in the quantum realm.